In this video, we will learn about what we mean when we talk about the field of chemistry. Chemistry is all around us. We will investigate how chemistry relates to other sciences and specifically physical sciences. So how does chemistry relate to other sciences? All the fields or areas of science are ultimately related somehow. This simple pyramid shows how mathematics, as well as logic, statistics, and theoretical computer science, forms the basis for all science. The next layer, physics, depends largely on mathematics. If you have a good understanding of math, this will greatly help in your understanding of physics. In a similar way, physics is the foundation for the field of chemistry. Many chemistry discoveries, but not all, over the centuries have been possible because the experimenters used some knowledge of physics in their chemistry experiments. The next layer is biology, whose building blocks are biological chemical molecules. So we can see that the foundation for biology is really chemistry. These four layers are arguably the four fundamental areas of science, with all other areas of science fitting in somewhere in the pyramid. For example, we can add in this top layer on the pyramid the study of human behavior, or the human sciences, which include sociology and psychology. The layers of the pyramid can be grouped into the formal sciences, the natural or pure sciences, which include the life sciences and physical sciences, and social sciences. Now, chemistry is a natural science. Natural science is the study of the rules governing the physical or natural world and the universe. Chemistry is also a physical science. Physical science is a branch of natural science that studies non-living systems. Now, there are many subfields of study which fit into the different layers. Subfields often overlap between the different layers and are actually interdisciplinary. Now let's take a closer look at the physical sciences, of which chemistry is a part. The physical sciences of physics and chemistry can be further broken into their subfields or subtopics. Here are just some of the subfields of physical science. It's hard to list these topics on a pyramid because they are closely related to each other and interconnected. A web such as this is perhaps a better way to show how these areas relate to each other instead of a pyramid. We could extend this web far and wide and make it very detailed by adding in all the non-physical science topics shown in pink. These complicated webs are more realistic. For example, a materials scientist would need knowledge of both physics and chemistry, while an oceanographer would need an understanding of chemistry, geology, physics, not to mention other science topics not listed here, like geography and meteorology, which is the study of weather. I hope you are starting to see that chemistry really is a central science. So, what exactly is chemistry? A nice formal definition for chemistry is the study of the substances matter is made from, their properties and uses, and how and why different substances interact or react with each other. We could summarize this definition looking at these key words. Chemistry is the study of substances, their properties, uses, and interactions. In other words, it is the study of different elements, atoms, ions, molecules, materials, solutions, states of matter, colloids, acids and bases, chemical laws, properties and characteristics, bonding, energy changes, reactivity, and so much more. The periodic table is a primary tool for understanding a lot of the basics of chemistry. Now, where is chemistry? That's a bit of a strange question. And the answer is very simple. Chemistry is everywhere. In paints, plastics, metals, drugs and medicines, dyes, fireworks, in the cells of living organisms, in the atmosphere, in the soil, cosmetics, in the hardware for technology, food, and even the stars. Now we know that there are many branches of science and that in the real world they overlap. We know what chemistry is and that it is everywhere. Let's take a closer look at the branches of chemistry. Chemistry is multidisciplinary. It has different branches, just like the branches of a tree. The 6 main branches are physical chemistry, which is the study of atomic properties, rates of chemical reactions, energy changes during reactions, and the structure of materials. Organic chemistry, which is the study of compounds based on carbon as well as hydrogen. Because of carbon's abundance in the earth and its ability to form 4 bonds, millions of compounds are carbon-based. Inorganic chemistry. This is the study of compounds without a carbon backbone. Although this is just a general definition for this field of chemistry, some inorganic compounds do contain carbon. This field deals with salts, metal compounds and transition metal compounds, minerals and materials. Analytical chemistry is the study of the composition, separation, and quantification of matter. An analytical chemist knows how to separate the components of matter, how to identify these components, and how to determine how much of each component there is. Analytical chemists are often involved in forensic analysis. Computational chemistry is a field of theoretical chemistry which uses computer simulations to solve chemical problems. These chemical problems could be in the field of physical, organic, inorganic, analytical, or even biochemistry. Many advances in the synthesis of new medicines and drugs are first studied computationally on a computer. And lastly, biochemistry, which is the study of chemical reactions and processes in living organisms. In reality, these branches often overlap. Many amazing discoveries over the centuries have opened up this vast field of study. But what does the future hold for chemistry? The possibilities of scientific discovery are potentially endless. Some of the hot topics at the moment in chemistry include new ways of drug delivery. For example, some researchers are using interesting nanoparticles to deliver drugs into the body to target specific tissues. Liquid crystals. These liquids exhibit the regular structure of a solid crystal lattice. You may have heard of LCD panels or liquid crystal display panels. These are electronically modulated optical devices and have many applications besides TV time. A big shift in research and in industry is towards sustainable and green chemistry. The focus is on minimizing or eliminating the production of hazardous substances or waste products. And the purpose is to protect our environment. Solar cells or photovoltaics convert light energy into electricity. This has a good link with sustainable and green chemistry, because fossil fuels do not need to be burnt to create the electricity. Another hot topic is nanomaterials and nanotechnology. This research investigates nano or near nano-sized particles and their many uses in medicine, catalysis, materials, and even energy storage. Femtochemistry is a relatively new area of study. The father of femtochemistry is Egypt's own Ahmed Zewail. He won the Nobel Prize in 1999 for his research in this new field of study. He used ultra-fast laser techniques to study chemical reactions over a time order of only femtoseconds. A femtosecond is a million billionths of a second. another famous Egyptian researcher, the chemical physicist Mustafa El-Sayed, developed rules for spectroscopy. Spectroscopy is the study of spectra produced when matter interacts or emits electromagnetic radiation. Professor El-Sayed is a U.S. National Medal of Science laureate. Zewail and El-Sayed are just some of the world's scientists at the forefront of chemistry discovery. Who knows, maybe you will be one too. Now it's time to practice what we've learnt. Chemistry can be classified as a physical science. Which of the following is not physical science? A. Physics, B. Astronomy, C. Earth science, D. Materials science, or E. Biology. The sciences, in general, can be grouped into mathematics, physics, chemistry, biology, and human behavior. This pyramid is a simple way to show how mathematics could be argued to be the foundation for all science, how physics is dependent on mathematics, how chemistry is based on physics, biology on chemistry, and human behavior or human sciences in part on biology. Mathematics and its related disciplines are called the formal sciences. Biology, chemistry, and physics are called the natural or pure sciences. And human behavior, social sciences. Natural sciences can be further split into the life sciences and physical sciences. The question tells us that chemistry is a physical science. The physical sciences studies the non-living systems of the natural world and universe and the rules which govern them, while the life sciences studies living systems and the rules which govern these. The two main disciplines in the physical sciences are physics and chemistry. The simple pyramid is a useful way to show the first-level grouping of the sciences. However, it does not show how the different layers of the pyramid interrelate and connect to each other. There are many subcategories linking the different layers. For example, although astronomy is not shown on this pyramid, it has to do with chemistry and physics, and even some mathematics. We could say that astronomy is a physical science. The question asks which of the answers is not physical science. Astronomy is not an answer because it is a physical science. And so is physics. Material science is a physical science. Its study has largely to do with chemistry and physics. We can also rule out earth science. Earth science also encompasses large areas of chemistry and physics study. We can see that biology is a life science. So this is the correct answer. So which of the following is not physical science? The answer is biology. Let's wrap up this question of what is chemistry with some key points. We learned that chemistry is the study of the substances that matter is composed of, their properties and uses, and how and why different substances interact or react with each other. We looked at a pyramid of the different sciences and saw that chemistry, together with physics, is a physical science. We noted that though this pyramid is useful, it is difficult to show on it how the different branches of science interconnect and relate to each other. We learned that chemistry is all around us and that the branches of chemistry can be broadly categorized into physical chemistry, organic chemistry, inorganic chemistry, analytical chemistry, computational chemistry, and biochemistry.